Today we are going to talk about a problem called rotting oranges. The problem statement says you are given an m cross n grid where each cell can have one of these following. Okay, for example, we have a grid, something like this. It can have 0, 1, 2, whatever it is, right? 1, 1, 1, 0, 1, 2, something like that. 0 represent empty cell. That means there is nothing in it. 1 represent a fresh orange. This is actually a fresh orange, which is nothing but like this. Okay, these are 1. 2 represents rotten orange, like this. This is actually rotten orange. 2. So for each and every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. For example, this is a rotten orange. After a minute, this will become, this is actually fresh orange, this will become rotten. This is also fresh orange, this will become rotten. That's what the problem statement says. Return the minimum number of minutes that must elapse until no cell has a fresh orange. So what they are saying is like after how many minutes, okay, this entire oranges which is there in the grid will become rotten. Okay, is this possible? Is there any possibility, or like if we can make it all the oranges which are there in the grid can be made rotten, then return the number of return the time. If we can't make all the oranges, then return -1. That's what the problem statement says. Okay, let's talk about how do we do it. Okay, first what we have to do is, in this is actually the problem. Okay, first find out how rotten oranges positions, okay, and put it in a queue. So this is actually a problem which can be solved using a breadth first search, because we have to find out minimum number of minutes. Whenever we wanted to find out minimum number of minutes, that means it's actually a shortest path related, and it's not a weighted graph. Then we can use to find the non-weighted. It's actually shortest path problem and non-weighted graph as well. Okay, we can use BFS to solve BFS. We need to have a queue. So we have a queue, and we first put this position, which is nothing but 0, 0. Okay, this is a queue, and pop this out, and then actually start pushing the neighbor are these two. Okay, push this neighbor, which is 0, 1 and 1, 0. Okay, once we make these two as rotten, actually whatever we see here, we made these two as rotten. Okay, then increment the counter 1. Okay, we also keep a counter and increment that counter by 1. Now explore these neighbors, these neighbors. The neighbor of this is this 2. Okay, make this rotten. Okay, the neighbor this guy's neighbor is already made rotten, so we don't need to, like, this becomes the second level. Okay, then you keep adding this into queue and this into queue. You keep continuing this. Actually, is actually kind of, you can see this is a 1 level. Okay, this is 2 level, this is 3 level, this is 4 level, and this is what we are going to return. So it's a simple BFS based implementation to return. So one thing which we have to note is edge cases. Let's suppose there is one more oranges here. Okay, if it is here, then we can't reach from here because there is no neighbor. Like, this is a kind of independent guy, so then we can't return the stages. We have to return -1, because for sure this cannot